Bonjour, welcome to Wahsa Citizens Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You are always welcome to join me live for the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 2 until 3 in the afternoon, and we are in our second week of our 9-week course. Soon you'll be able to submit work. We'll have covered enough lessons that you'll be able to submit work. So a reminder that the support questions, the ones with the pencil icon, are not for marking. You decide which ones and how many to do. If you are understanding a concept, feel free to skip some of the support questions. You don't have to do them all just because they're there. You know what is best for you. However, if you need more practice, you want to work on something, let me know and I'm happy to find more practice for you. The answers are in the back of your booklet and I strongly encourage you to use them. They're there for a reason, so you can check your work to make sure you're on the right track and get some support. So please check your work and then move on to the key questions. The key questions are the ones with a little key icon, and these are the ones to submit for marking. So please do all of these questions. Don't skip any. Don't replace any with support questions. I will notice. So please do all the key questions and show all your work and your thinking, your steps. This way I can understand what it is that you understand. And if you're struggling with something, if you have a problem, if you're making consistent error, I'm able to see what's going on, opposed to you just give me the final answer, then I have no idea how you got that number and I can't actually help you learn. So how do you actually submit your work for marking? Well, there's 3 methods. The first method is to scan your work and send it electronically. If you have a device, you can scan your completed work using that device. The Apple devices have a Notes app and the Android devices have a Google Drive app. If you're not sure how to scan using these apps, I have a tech tutorial on my YouTube channel that you can check out and it'll walk you through how to do that if you need support, or you're welcome to ask me and I can walk you through it as well. Once you've scanned your file, you can send it through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our 74 Front Street location. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. If you want to hand in your work, your actual written work, just drop it in that box at any time and I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my YouTube and my Facebook are under the name B. Slate Wahsa. So you can friend me on Facebook and subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our videos. All of our radio Zoom classes are recorded and I upload them generally within 24 hours of airing. And I put them under a playlist called MBF3C, which is our course code. I also have short videos on my channel that explain common errors and confusing concepts. So it's a really good place to go, and if you're struggling with something, that I might address it directly there, and you just don't generally have to do a general internet search and sift through everything on the world. So it's a good place to start. Math is a really visual subject, and I work specifically to make it to connect to the visuals as much as possible, as that's something that many areas are lacking. But this is a way that I find students understand the best. However, that means that you need to actually connect with the videos. You can't just listen on the radio. You can, you just don't get as good of a full experience. So I strongly encourage you to access the videos either by joining me live through Zoom. Whether or not you talk to me, that's separate. You don't have to, even if you're here. Or you can watch the videos replayed on YouTube whenever it's convenient for you. If you don't have access to reliable internet, which means that you can't join through Zoom or access the YouTube channel, just let me know and I'm happy to send you a copy of the recordings so that you get the full experience and really can set yourself up for success. If you have any questions or concerns, if you're struggling with anything, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslate Wahsa. You can call me at the office at 807-737-1488, extension 2209. You can call toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m., though I teach the last hour of my day, so that's not a great time to try to get a hold of me. All right, we're diving into lesson 4 today. This will be a 2-part lesson yet again. There's a lot of stuff at the beginning of this course that we really need to make sure we're understanding as we're moving forward. They're pretty dense lessons. There's not as many as we move forward. But we're looking at exponent laws today, and this can be something that can be pretty confusing for folks. So I broke it up into 2 lessons. So this lesson and the next one will both be on lesson 4. Our learning goals are that at the end of this lesson, you will be comfortable calculating simple powers, and you will understand the logic behind exponent rules. You know that you've met the learning goals because you can execute with comfort the multiplication, division, and power of power rules, which is what we're going to focus on today. And you can explain the reasoning behind zero and negative exponents, which is what we'll do next class. So, as always, asking the question, when we'll use this in real life? Well, we're developing the skills to attack problems. So this stuff can be really confusing, but in our lives, problems always arise. So having the ability to figure out what you know, what you don't know, what tools you have, what tools you need are all really important skills, making connections so that you can attack these problems and solve the problems in your life. So that's part of the skills that we're developing. But first, let's activate your brain with some mental math. I don't believe in mad math minutes. They cause stress and anxiety and don't actually teach skills. Instead, we focus on using strategies that feel comfortable and using numbers that make sense to us in order to do all of our math facts. So today's question is 36 times 12, and we're going to use the strategy of doubling and halving. So what doubling and halving means is that we're going to take one of our 2 factors, so one of our 2 numbers, 36 or 12, and we're going to double it, because doubling generally are numbers that work well for us. So as we double one number, we're going to half the other number. We're going to cut the other number in half in order to compensate for the fact that we've doubled the other one number. So I'm going to double 36. So I'm going to times 36 by 2. And as I do that, I'm going to cut 12 in half. So I'm going to divide it by 2. So 36 doubled is 72. And 12 cut in half is 6. So 72 times 6 still isn't really a friendly thing, so I'm going to do it again. And that's the nice thing about doubling and halving, is that you can just keep doing it. You want to continue doubling the same side and having the other side, just so that you don't get yourself back in the same place that you were before. So 72 times 2, so doubled. Well, 70 doubled is going to be 140. So 72 doubled is going to be 144. And then 6 cut in half is 3. Now, cutting 3 in half is not super friendly. It's not really easy, because then I'm going to get 1.5, which is not going to be awesome for me. But so basically now I'm at the point where I need to just do my multiplication. But 144 times 3 might be something that feels a little bit easier. So for me, I'm going to then think about this. Well, 3 times 100 is 300. 3 times 40 is 120. So that means I have 420. And 3 times 4 is 12. So I have 452. So though it doesn't necessarily make it, it's still, your number still might be tricky. 36 times 12 would be really hard for me to organize in my head, but 144 times 3 was a little bit easier for me to organize in my head. And so by doubling and halving my factors first, made it a little bit more straightforward for me to do it mentally. All right, mine's on. We're just going to review exponents first before we dive into the exponent laws. It's just important to understand what it is that we're talking about. So we have the base, which I have representing as a blue circle on my screen. And this is our number, the bigger number at the bottom. And then we have the exponent, which is a smaller number that is up to the top right of the base. And then this whole thing all together is called the power. I'm not going to be too picky about if you call it a power or not, but just so that you know the language. So an exponent, the whole how an exponent is like an operation, how it works is that the actual exponent states how many times the base value is being multiplied by itself. So for example, if I have my base of this blue circle to the exponent of 5, I have 5 up where my star is in my little exponent, then that means that it's the circle times the circle times the circle times the circle times the circle. That is what a power means, is that you are multiplying the same value by itself the number of times the exponent. So we're going to do lots of examples working through this, but just that's what we want to define. Remember that. So if we look at this with numbers, we have 4 to the exponent 3 is equal to 4 times 4 times 4. So our base is 4, our exponent is 3. That means that we are multiplying 4 by itself 3 times. If I have 2 to the exponent 8, that means I'm doing 2 times 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 2. As you see on my screen, I have little fingers. Sometimes you need to count it out with your fingers. Totally fine to keep track. No worries. Fingers are your useful tools. -7 to the exponent 4 is equal to -7 times -7 times -7 times -7. So -7, 4 times that you're multiplying it by itself. With variables, how we write this down, if we have x to the 5th, we don't write it down with multiplication signs because multiplication sign looks like an x. So here I have written on my slide x times x times x times x times x, which is accurate, but it's really confusing looking. And if I were writing this out by hand, it would be much more messy. You wouldn't really understand how many x's I'm talking about. So instead, if we're wanting to write out the long form of our exponent of our power, then we use these little dots to indicate multiplication. So we have x times x times x times x times x. It's the same. We're going to say the same thing, but it's just a note of the way that we write it down, the notation. It keeps it a little bit cleaner. So a squared is equal to a times a. T to the exponent 10 is equal to 10 times, t times 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 t. Again, you can see why we use exponents, because writing them all out, you can end up having to write a lot of stuff down. But understanding this is really important as we try to understand why our exponent rules work as we're moving forward. It's also important to know your calculator buttons. So on your calculator, if you are doing something squared, a number squared, it's going to be most likely x to the exponent 2. It might be a to the exponent 2 or b to the exponent 2 or y to the exponent 2. It's always going to be the exponent 2 because that means squared, but most likely it's x to the exponent 2. You'll most likely have that button on your calculator. But if you want any exponent, because we're not just working with squareds anymore, we're not just working with 2 as our exponent, then you could have any of these buttons. So you could have x to the exponent y, or y to the exponent x, or a to the exponent b, or you might have even this button, this last button that I have, which is like a little hat. I cannot remember what it's called. I looked it up before and I forget. But it's kind of like the top part of a little triangle, sort of, or like a little tent. So that is if you're in computer science or you're writing computer code, that is how you indicate an exponent, with this little symbol, and that could be on your calculator. So how you do it is that you would press your base, then whatever button you have on your calculator that represents your exponent, and then your exponent number, and then it would calculate it for you. If you're not trying to use your calculator, you need some help, let me know. Being able to use your calculator is super important. Okay, so what do we need? What are we learning about today? Let's dive into our new concepts. We're first going to be looking at multiplying powers. And this is on page 26 of your IL booklet. I am going in the order today that is in your book, just so you know. So when I say multiplying powers, I mean, how do we multiply powers with the same base? So what this means is that if I have a question like 2 to the exponent 4 times 2 to the exponent 3, what does that mean? How do I simplify that? So if I have 2 powers and I'm multiplying them together, what is my answer? How do I figure that out? Yes, we could just put this into a calculator. Totally we could, but eventually we are going to have variables and we're not going to be able to just put into our calculator. So it's important to understand how to combine how to manage those situations when we can't just use our calculator. But we're going to start with calculating using numbers so that it makes hopefully more sense. So 2 to the exponent 4 times 2 to the exponent 3 is equal to 4 times 4 times 4 times, my bad. This is totally why we practice, because it's easy to make these mistakes. 2 times 2 times 2 times 2, which is 4 times, and times 2 times 2 times 2, which is 3 times. So that's how we would expand it out if we wanted to expand this, which is really just the same as 2 times 2 times 2 times 2 times 2 times 2 times 2, which is 7 times. So 2 to the exponent 4 times 2 to the exponent 3 is equal to 2 to the exponent 7. Really, this is just the same thing, because I'm just saying that I have 2 that I'm multiplying by itself 7 times when I'm doing 2 times itself 4 times 2 times itself 3 times. So writing this all out is a bit annoying. So our rule, our exponent law for multiplying powers, is a shortcut, a way that we can make our life a little bit simpler. So 2 times 4, sorry, I'm having a hard time today tracking my brain, I apologize. 2 to the exponent 4 times 2 to the exponent 3 is equal to 2 to the exponent 4 plus 3, where 4 plus 3 is in our exponent. So 2 to the exponent 7 is our shortcut, because 4 plus 3 is equal to 7. So that makes our lives a lot easier. We can just, and when we're multiplying power to the same base, we can just add our exponents together. So let's do this with a letter to see if this is going to always be true, or if it's just because of we have 2. So if we have 2 to the exponent, if we have x to the exponent 2 times x to the exponent 6, then we have x times 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 x. So really, we just have x times 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 x. We have x to the exponent 8. Because all we're doing is multiplying, that means that we're doing the same thing all over again. So the shortcut works as well, where we have x to the exponent 2 times x to the exponent 6 is equal to x to the exponent 2 plus 6, which is equal to x to the exponent 8. So our multiplying power rule is that when we multiply powers with the same base, we add the exponents. So anytime you're multiplying two exponents, two powers, so numbers with exponents, if they have the same base, all you need to do is add their exponents. You don't actually have to write them all out to figure it out. You can just add the exponents. So one thing that I keep saying is the same base. So we want to make sure that we understand why the base must be the same. So let's look at numbers. If we have 1 to the exponent 3 times 9 to the exponent 2, that means we have 1 times 1 times 1 times 9 times 9. So we have 3 1s times 2 9s. So 1 times 1 times 1 times 9 times 9. Well, this doesn't make any sense that we have 5 because we don't have 5 of the same thing, right? So we can't just say that we have something to the exponent 5. We can't add these exponents because we don't have the same base. We don't have 5 1s and we don't have 5 9s. So this doesn't make any sense. Now, most likely, you're not going to do this with numbers, but people do this with variables all of the time. So x to the exponent 4 times y to the exponent 7 is equal to x times x times x times x times y times y times y times y times y times y times y. So does it make any sense to have x times x times x times x times y times y times y times y times y times y to be anything to the exponent 11? Well, can it be x to the exponent 11? No, I don't have 11 x's. Can it be y to the exponent 11? No, I don't have 11 y's. So I can't add 4 plus 7 to make this to be anything to the exponent 11. Many times I would see, I'm going to write the wrong thing down so you can see. Many times I might see x 11y or x y 11. But that doesn't make any sense. You're not saying that I have 11 x's or 11 y's, and I do not. I still only have 4 x's and I only have 7 y's. So I cannot, I can't combine them because they're not like terms. They don't have the same base. All right, that's super, super important. So throughout, I'm going to keep saying things that have the same base, but this is why the reason why always applies, because we can't combine things if we're not talking about the same thing. Okay, so let's do a little bit of practice with that before we dive into our next rule. So practice question number 1, write each expression as a single power and then evaluate. So for part A, I have 3 to the exponent 2 times 3 to the exponent 4 times 3 to the exponent 3. So this, and I'm going to use, so writing it as a single power means that I'm going to write 3 as my base to the exponent of one number, and then evaluating it, we're going to use our calculators. So here, I'm not going to write out all the steps. I'm just using the shortcut because that's what we're learning, is we're learning the shortcut to make our lives easier. So 3 is my base. So I'm going to have 3 to the exponent 2. Now I'm multiplying, so that means I do 2 plus 4, and I'm still multiplying, so 2 plus 4 plus 3. So that equals 3 to the exponent 2 plus 4 is 6 plus 3 is 9. So this as a single power is 3 to the exponent 9, which if I evaluate, I'm going to use my calculator, my Desmos calculator. You can use your own calculator. I'm going to do 3 to the exponent, and you can see here, a to the exponent b is my exponent button. 3 to the exponent 9, and then you can see how it's written on my Desmos calculator is that it's set my 9 as a superscript up in the top right, and then I get 19,683. So you could do it by hand, but multiplying 3 by itself 9 times is a lot. You got a big number, so I don't expect you to do it by hand. Use your calculator, totally fine. All right, part B. We have -1 to the exponent 3 times -1 to the exponent 2 times -1. Now here, when I have no exponent, we can see that If I don't have an exponent there, what is the invisible number? Well, I'm just having a negative, it's just -1, means that I just have it one time. That's why I don't write down 1. Because mathematicians are lazy and we try to make our lives easier by not writing things down sometimes. But if I'm combining my exponents, and I have -1 is my base, and then I have 3 plus 2, and then I still have to add in that 1, even though it's invisible here in this term, it still exists, so I still need to add it when I am adding my exponents together. So that means that -1 to the exponent 6 is my single power, and then -1 to the exponent 6 is, using our calculator, -1 to the exponent 6. So here is negative, they're saying it's -1. Now, that I knew it wasn't, I wasn't expecting it to be -1. I wanted it to be, so it's because I didn't put the brackets in. See, when I put the brackets in, now you can see that it changes to be +1. So it's really important if you're using Desmos or if you're using your calculator that you pay attention when you're having negatives, what's going to happen, because I knew it was going to be, because I knew it was going to be a +1. And so when my calculator didn't give me that, I knew that that was wrong. So don't always trust your calculator. You be smarter than your calculator. So then we have, for part C, we have 3/4 to the 5th times 3/4 to the 3rd. So here again, even though I have 3/4, which doesn't feel like a friendly number, that's just my base. It doesn't matter what it is. My base can be anything. But then I'm adding my exponents, 5 plus 3. So that means that I have 3/4 to the exponent 8. And so if I use my calculator to do that, I'm going to put brackets in this time just to make sure. So 3/4 to the exponent 8 is equal to 0.100112915, or you can convert it to a fraction and you can get it to be 6. That doesn't really matter. It's not a friendly number either way. So we're just going to say approximately 0.1001. And that is practice question number 1. So number 2, we're going to simplify it with, if we have variables, so x to the exponent 4 times x to the exponent 7. So x to the exponent 4 plus 7, we get x to the exponent 11. We can't simplify it any further because we just have a variable, so that's where we stop. Then -y to the exponent 2 times -y to the exponent 3 times -y to the exponent 9. So we have -y to the exponent 2 plus 3 plus 9. 2 plus 3 is 5 plus 9 is 14. So you have -y to the exponent 14. Again, that's all we can do to simplify it. Part C, we have 6n times n to the 6 times m to the 2nd times n times m to the 5th. So here we need to look and we need to say, okay, well, we have n to the 6th times n, and then times m squared times m to the 5th. So I'm gathering my like terms. And then I have n to the 6 times n is going to be n to the 6 plus 1, and then times m squared times m to the 5th is going to be m 2 plus 5. And so that means that I end up with n to the 7th, m to the 7th as well. So then that's the end. We can't do anything else with it, so we just leave it there. All right, so now we're going to move on to our next rule, which is dividing powers. So how do we divide powers with the same base? So 8 to the exponent 6 divided by 8 to the exponent 3. So we're first going to expand this to figure out what's going on here. So if we expand this, we have 8 times 8 times 8 times 8 times 8 times 8, because we still are multiplying because that's what an exponent means, divided by 8 times 8 times 8. Now I've first written this out with linearly, like on a straight line with the little division symbol. Usually I don't think about it like this, so I'm going to rewrite it as a fraction where I have 8 times 8 times 8 times 8 times 8, so 6 8s on the top, and 8 times 8 times 8, 3 8s on the bottom. So I'm still dividing. This is exactly the same thing. You can technically write it either way. This is just how I think about it and how I'm likely to write it in class when we're doing other things as well. So with this, when we are multiplying a number by a number and then dividing by that same number, well, when we multiply 8 divided by 8, 8 divided by 8 is just 1. So it doesn't actually change anything. So we can cancel off an 8 divided by an 8 on the top and an 8 on the bottom because 8 divided by 8 is just 1. Because it's like we have a whole. So then I have another 8 that I'm multiplying by and another 8 that I'm dividing by. So I can't cancel that off as well because I'm just multiplying and dividing by the same thing. It doesn't change anything. And then I can do it a third time, 8, because I'm multiplying by 8 and I'm dividing by 8. So that means that a third time I can do it and they just cancel off. So that means that I'm left with 8 times 8 times 8 divided by 1. So that is just 8 to the exponent 3, because anything divided by 1 is just that same thing, right? So 8 times 8 times 8 divided by 1 is just 8 times 8 times 8. And 8 times 8 times 8 is just 8 to the exponent 3. So again, we're trying to figure what the shortcut is. So the shortcut, the rule, is that if I have 8 to the exponent 3, 6 divided by 8 to the exponent 3, I just get to subtract my exponents. I just do 8 to the exponent 6 take away 3, which is 8 to the exponent 3. So let's look at a example with variables. So we have b to the exponent 9 divided by b to the exponent 7. Here I've written it as in like a fraction way, still the same thing, still division. So that means that I have b times itself 9 times divided by b times itself 7 times. And again, you can see those b's are going to cancel each other off. So you can just go through and you cancel one on the top and one on the bottom and one on the top and one on the bottom. And you're going to do that until you run out of either b's on the top or b's on the bottom, wherever that ends up. So I've done that 7 times. So I'm left with just b times b divided by 1, which is the same as b to the exponent 2. And so the shortcut still works, where b to the exponent 9 divided by b to the exponent 7 is equal to b to the exponent 9 take away 7, which is b to the exponent 2. So our dividing powers rule is that when we are dividing powers with the same base, we subtract the exponents. And this always will work. So let's do some more practice. So number 3, write each expression as a single power and then evaluate. So this time we're doing the same thing we were doing before, but now we're dividing. So for part A, we have 7 to the exponent 15 divided by 7 to the exponent 4 divided by 7 to the exponent 3. So if I'm writing this as a single power, my base is 7, and then I'm going to have 15 take away 4 take away 3, which is equal to 7. 15 take away 4 is 11. 11 take away 3 is 8. So 7 to the exponent 8. And then if we're going to evaluate that, we have 7 to the exponent 8, which is 5,764,801. So these numbers get big really quickly. That's how exponents work. All right, part B, we have -2 to the exponent 3 divided by -2 to the exponent 2 divided by -2 to the exponent 1. So we have -2. Sorry, I should have changed this and I don't know why I didn't. Anyway, 3 take away 2 take away 1 is equal to, well, 3 take away 2 is 1 and 1 take away 1 is 0. So -2, this equals -2 to the exponent 0. We will spend time in our next lesson figuring what that actually means, but we can still evaluate it. We'll learn about why this works. So we have -2 to the exponent 0, and our answer is 1. That might not make sense to you right now, totally fine. We're going to learn about why that is true in tomorrow's class. And then we have part C, where we have 2 to the exponent 5, n to the exponent 8, divided by 2 to the exponent 3, n to the exponent 6. So here, again, we do the parts that have the same base. So we have 2 to the exponent 5, take away 3, n to the exponent 8, take away 6, which means we have 2 to the exponent 2, n to the exponent 2. Can we evaluate that? Well, we can evaluate the 2 to the exponent 2. So 2 squared is 4. So that ends up being 4n squared. And that's as far as we can go because we don't know what n is, so that we have to stop there. All right, 4, we're going to simplify. We have Z14 divided by Z3. So Z14 take away 3 is going to equal to Z to 11. That's all that we're going to do, all we can do. Here we have negative a to the exponent 8 divided by negative a divided by negative a squared. So again, we have negative a, then it's 8, take away 1, take away 2, which is equal to a to the exponent 8 take away 1 is 7, 7 take away 2 is 5, so a to the exponent 5. And then part C, we have w to the 8th x squared y to the 5th divided by w third y to the 4th. So these ones can be overwhelming because it just feels like there's a lot, but we just take it piece by piece. So we have to look at the same base. So we have w 8 to the 8th divided by w to the 3rd. So that means it's going to be w 8 take away 3. Then we have x to the squared take away, well, there's nothing. There's no x on the bottom. So x squared is just going to stay the same. And then we have y 5 take away 4. So w 8 take away 3 is 5, x squared stays the same, and y 5 take away 4 is 1, so it's just y. And that's all we need to do. And that is the division rule. So then we have power to a power. This is also on page 26. They squeeze a lot in your workbook. So how do we raise a power to a power? What does this even mean? So we're going to go into a little bit more of an explanation for this one. So we have a number to the exponent 5. So I have a blue circle. So just to represent our base, we know that this is our circle times our circle times a circle times a circle times a circle 5 times. But if instead of that circle, I have 4 to the exponent 2, well, that means that I now, instead of that, every time I see that circle, I have 4 to the exponent 2. So I have 4 to the exponent 2 times 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 4 to the exponent 2. But 4 to the exponent 2 is actually 4 times 4. So that means I have 4 times 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 4. Which really is just 4 times 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 4. Again, this is why looking at the visuals really helps, because just listening to me say that doesn't mean anything. But really what that is that I have 4 to the exponent 10. I have 4 10 times that I'm multiplying 4 by itself. So our shortcut, because that's awkward, if we have 4 to the exponent 2, all to the exponent 5, really what we can do is we can do 4 to the exponent 2 times 5, because we have 4 to the exponent 2, all of that 5 times. But then for every 4 to the exponent 2, we have 4 times 4. So really we end up with 4 to the exponent 10, because 2 times 5 is equal to 10. And so that's our shortcut. So let's look at an example with variables. So if we have y to the exponent 9 times, y to the exponent 9 to the exponent 4. So this means that we have 4, we're doing this 4 times. and we're doing y to the exponent 9 times y to the exponent 9 times y to the exponent 9 times y to the exponent 9. But for each of those, we have 9 y's, and I'm not going to say all those y's. So I have 9 y's 4 times. So that means that I have 36 y's. So that's just y to the exponent 36. This is why you can see once we start getting bigger numbers and more complicated numbers, having to write it all out is not a convenient, helpful thing. Using the tool, the shortcuts, the rules, makes much more sense. So the shortcut is that y to the exponent 9 to the exponent 4 is the same as y to the exponent 9 times 4, which is equal to y to the exponent 36. So our power to a power rule is that when you are when you're raising a power to a power, you multiply the exponents. So here, if we have something that's complicated, like we have multiple terms in that we're raising to a power, this is something that happens frequently and people often make this mistake. So for example, I have -6 times x to the 4th times y to the 2nd times z, all of that to the exponent 3. Well, that means that we have whatever's inside the brackets 3 times, right? That's what that to the exponent 3 means. So we have -6 x 4th y squared z times -6 x 4th y squared z times -6 x 4th y squared z. So we can rearrange that so that we're grouping our like terms. So we have -6 times -6 times -6 times x to the 4th, x to the 4th, x to the 4th times y squared, y squared, y squared times z to the 1, z to the 1, z to the 1. So we've just rearranged our same information so that we've collected our same bases. So -6 is going to be 1 to the exponent, to the exponent 1 times 3, then times x, which is to the exponent 4 times 3, then it's y to the exponent 2 times 3, then it's z to the exponent 1 times 3, which is -6 to the 3rd times x to the 12th times y to the 6th times z to the 3rd. So you can see that what's key here is that in your original question, your 3rd exponent, you have to apply to each of the things inside of the brackets. You can't just do it to the number. You can't just do it to the letters, the variables. You have to do it to every single part of the term. And that's what people make the mistake for a lot, is that they might do it to part of it, but not the whole thing. So when you have multiple terms that you're doing a power to a power, you need to do it, sorry, not multiple terms, but multiple parts of your term, you need to do it to every single part. Then you can do -6 to the exponent 3. You can simplify that to be -216, x to the 12th, y to the 6th, z to the 3rd. And then you're done. All right, so let's do a little bit of practice with these power rules. So number 5, write an expression as a single power and then evaluate, just like we've been doing. So we have 5 to the exponent 2, all to the exponent 7. So that means we have 5 to the exponent 2 times 7, which is equal to 5 to the exponent 14, which is equal to, on our calculator, 5 to the exponent 14, which is equal to a huge number that it doesn't even make sense to write down because it's just so big that it doesn't make any sense. So it's too big. We're not going to evaluate it. Just makes things more confusing. So then we have part B, we have -3 all to the exponent 8 all to the exponent 6. So that means that we have -3 to the exponent 8 times 6, which is equal to -3 to the exponent 48, which again is going to be huge. -3 to the exponent 48 is also huge. So again, we're not going to write it down. And then we have part C, we have 2/5 to the exponent 2, all to the exponent 3. So our base is 2/5 to the exponent 2 times 3, which is equal to 2/5 to the exponent 6. And so then if we were to do that on our calculator, you can see 2/5 to the exponent 6 is equal to 0.004096. That one's not too much of a pain to write down. And that's how we would do evaluating those powers. Then if we're doing it just with variables, we have part A for number 6, we have p to the exponent 2, all to the exponent 5. So p to the exponent 2 times 5, which is equal to p to the exponent 10. Part B, we have a to the exponent, negative a to the exponent 4 to the exponent 7. So that means that we have negative a to the exponent 4 times 7, which is equal to negative a to the exponent 4 times 7 is 28. Then part C, we have r over t, all to the exponent 3, all to the exponent 9. So that means we have r over t to the exponent 3 times 9, which is equal to r over t to the exponent 27. And this one we can simplify further because this is the same as r to the 27th over t to the 27th. Because it's like we have a power of a power again. It's just that we have r to the 1 and r to the t to the 1. And so we can simplify it such that the 27 applies to both parts. All right, so now you can do the practice questions on page 28. Questions 1B, H, and 2D. You'll get lots more practice, but you have to wait until we do the second half of this lesson. I know that these are the only questions that don't involve either 0 or negative exponents. So you're still going to get a lot of these practice with these types, but we need to understand 0 and negative exponents first, which we're going to do in our next lesson. So if you just want to do some practice after this lesson, check out 1B, H, and 2D. So a key point is answering the question, what is the question asking? So if it's asking you to evaluate, you're calculating a final answer. You're trying to find an actual number at your end. If they ask you to simplify, then they're asking you to combine exponents as much as possible, and you're most likely not going to get a final answer. So we don't actually have time to go through these practice questions. We're pretty much out of time. So we're just going to skip this through and consolidate. If you have any questions and you want to go through, we'll do more practice in our next lesson tomorrow. So check that out as well. They're very similar. If you are doing practice and you don't have any questions and you have questions, let me know. We can work through them together. So let's consolidate what we learned so far today with exponent laws. First key thing to remember with all of these laws is that you need to have the same base. That is super important. So our multiplying powers rule is that you add the exponents. So x to the exponent a times x to the exponent b is equal to x to the exponent a plus b, no matter what your numbers are. Our dividing power rule is that we subtract the exponents. So b to the exponent x divided by b to the exponent y is equal to b to the exponent x minus y. And the power to a power rule, we multiply our exponents. So t to the exponent n all to the exponent p is equal to t to the exponent n times p. And that is how we understand power of the power rule. So we've only covered success criteria number 1 that you can execute hopefully with comfort, the multiplication, division, and power or power rules. We will continue with this lesson in our next video to compute lesson 4 in our next class. Just wanted to give all of these enough time to really understand and be able to get some time in for practice. Though we didn't have tons today, hopefully we'll have them more in our next class. If you have any questions about any of this, please reach out. This can be really confusing, and it's stuff that is building blocks for many of the other things that we're coming for, that this stuff gets to the point where either you really understand it and you don't think about it, or you really don't understand it and it constantly catches you up and you're making other mistakes because this isn't going well for you. So please reach out if you're struggling with this. You can call me at the office at 807-737-1488, extension 2209. You can call me toll free at 1-800-667-3703. You can email me at bronwyn.slate, and my name is spelled BRONWYN.SLATE@nnec.on.ca. Connect with me through Facebook, where you can ask me questions through Messenger. I'm good at responding there. My name is B. Slate Wahsa. Check out this video as well as other videos on YouTube. I have a few videos that just go through the exponent laws individually. So if you need some more examples, there's more videos there about exponent laws, because this is something that happens and people struggle with. Don't worry if you're struggling, just get some more help. Remember, my YouTube channel is also called B. Slate Wahsa. My office hours are Monday through Friday, 9 a.m. to 3 p.m., except actually on Thursday, where I'm in from 10:15 to 4:15. Just the way life goes sometimes. But if you don't catch me, leave me a message, send me an email, and I will get back to you as soon as I am able to. Thank you so much for joining me today. I hope you have a lovely day. Miigwech.